Welcome to live star stream of UTA Planetarium. My name is Levent Gürdemir. I am astronomer at UTA, and today we are going to talk about something cool. Sky and Telescope magazine is a very popular magazine of amateur astronomers, and it just came with recently with this beautiful cover showing the McDonald Observatory of West Texas. So that reminded me my observational astronomy years, and in that cover, which is right over here, this is one of the telescopes located over at West Texas, so at the McDonald Observatory. So this reminded me my observational astronomy years, and frequently people ask me, how do we conduct science? So first of all, what astronomer does? Apparently, we are not the ones jumping into the space shuttles and going to space, and we are not the ones just going to the Mars. But we are doing a lot of science in the observatories, and the people and my friends and my colleagues frequently wondered what we are exactly doing in the observatories like this. So apparently,
yeah, definitely have to cut in there, Levin. I wonder the same thing. I mean, you go to these observatories, and do astronomers really need to use them all night? I mean, what do you do for 8+ hours? I mean, if it's winter, longer than 8 hours, what do you do for that much of a day or night?
Well, that reminded me when I was in college, I was living with my parents, and I was saying, hey, I have observation tonight, and I'm just going to come back in the morning. And they were like saying, why are you going all night long? Just come back at the midnight. So why do we need all night long? So let me explain why. So to understand this, first we need to find out how do we conduct science at as a professional astronomer at a professional observatory. So let's talk about this cartoon. So let's come back first. Come back one step. And in this cartoon, there's a big telescope, astronomical observatory. Everything is accurate, but look at these two scientists. One scientist is actually behind the telescope, looking to the sky using that big telescope. This is not what actually scientists do. They hardly any time go behind the telescope and look through the telescope actually. And in most observatories, there is not even actually a place that you can directly look into the night sky. So let's go forward. So here's the McDonald Observatory. I did my observation on this telescope. This is an amazing telescope built in 1954. It is a 107-inch giant telescope. So there are 3 telescopes on the mountain, and there are several more actually, but mainly for research these 3 are used. This building is a 5-story high, and there is a dome built on top of it. So I will explain the parts of the pieces a little later. So here is a telescope. This is just a gigantic version of a backyard telescope. So there is not much differences other than the size. Of course, there are giant motors and the mechanism moving that telescope, which is amazing. You can actually compare the size of the telescope with a person over here. So that's a very big telescope. So that telescope is located on the 5th floor of this building. So again, it's a 5-story. The telescope room is at the 5th floor. So to access the telescope, you need to go to the 5th floor. How about the 1st, 2nd, 3rd, and 4th floors? So the 4th floor is reserved for detectors, because the light, after it is collected after this telescope, it goes to the 4th floor for more observations. So let's move forward. Every telescope collects light. So this is the only function of the telescope. It collects light. The bigger the telescope, the more light you collect. And how do they collect light? They are collecting light through a mirror. So this is the mirror of the 107-inch telescope just we shown before.
Whoa. What are those marks on the telescope? I mean, the circle in the middle, I get. That's where another mirror would be. You'd lose light anyway. But what about these weird marks? all over the screen.
So that's a classified information you should never ask. I'm just kidding. This is a Texas telescope. So what do you expect to find in a Texas telescope? Those are bullet holes.
What?
I'm serious. Those are bullet holes. So the story is actually in the early 1970s. One of the mentally ill employee had a rough time and actually grabbed a gun and shot the mirror with the purpose of damaging a very expensive instrument.
So it was an employee.
It was an employee, yes, a mentally ill employee.
I mean, probably.
So he shot the mirror 7 times and then realized the bullets did not break did not shatter the mirror. So he took the further steps. He actually jumped in the telescope with a hammer and hit the hammer right over here and several other locations too, and still couldn't break the mirror. So the funny story is the police report said the employees severely damaged the mirror because the damage was there was a big hole at the center of the mirror. So I will explain the purpose of the hole later, but this hole is actually not from the damage that the employee caused. It was made that way, and there's a purpose for that.
Are they still using the telescope with bullet holes? How is it still any good?
It turns out the bullet holes and the hammer footprints did not steal a lot of area from the surface of the mirror. So mirror was still in usable condition, and the science was not affected because like more than 99% of the mirror was there intact. So that's why they decided not to replace that mirror, because that's very expensive mirror, and these mirrors are different than your bathroom vanity mirrors. Your bathroom mirrors are flat. These mirrors are not flat. These mirrors are precisely machined to have like a bent on the edges, so we call it parabolic mirrors. So they are a little curved surface, and the coating and everything is a very precise, delicate process. So what these telescopes do, so the telescope gets the light because the mirror is slightly bent on the edges. They divert the light to the center line of the telescope, and then there is a second mirror at in the front of the telescope. They divert the light back to the center of the mirror. So there is the hole that we seen in the picture. It was manufactured that way, and then the light leaves the telescope in a compact form, in a collected form. So that bunch of light goes to, well, here it shows eyepiece, but in the observatory cases, in the professional observatories,
so
it actually
the
goes.
holes, there wasn't enough room for them to do damage. You can still use it because they didn't even amount to the size of the hole in the base of the telescope.
Yes.
That's why they're able to use it.
Yes, when they calculated the size of the bullet holes and the size of the hammer's impact footprint, still they have the more than 99% of the mirror intact. So the science is not going to be affected, they realized, with the bullet holes. And they are still using today, using the same mirror. And you can actually, if you visit the McDonald Observatory, if you get the chance to see the inside of the telescope, you can still see the bullet holes.
Okay, so I have been to McDonald Observatory before, and I know that, I mean, we saw just a moment ago the whole mountain top with the 3 telescopes, but there are 2 normal-looking telescopes, and then there's a weird one, right? Can you talk a little bit about the weird-looking buckyball-shaped one?
Yes. So this is the classic telescope, but the manufacturing of these giant telescopes are very, very expensive. So many years ago, and I would say at least a few decades ago, they thought that the telescopes can be made in a little bit more cheaper way. And that way is, so you construct the telescope, and here is they call it Hobbyiberly Telescope, or with the designation HET. So this is almost 10 meters wide, so this is extremely large telescope comparing to the other telescopes I showed. And the challenge is you cannot make one giant piece mirror precisely machined at that diameter. So for that reason, they are not using one-piece mirrors. And let's see the structure of the telescope. So the telescope design is actually very different on this. If you pay attention to the mirror is not one giant piece. They are using the segments on the mirror. So it's a honeycomb shape pattern. So each one of these honeycomb segments are individual mirrors. Those mirrors are...
So with individual mirrors, do they all move separately?
They do. They are computer-controlled mirrors because depending on the object you are looking at, there is a lot of correction needs to be made on that type of large mirrors, because the problem is the mirrors do not treat every individual light the same way through their surface. So there are impurities that the computers needs to compensate. So for that reason, every segment is computer controlled. They have different type of alignment. Another difference is in the structure. Look at, you don't see a solid tube on these telescopes. There is a lightweight truss system. And that's because constructing the solid walls is expensive and makes the telescope extremely heavy. And you need to rotate that telescope with motors. So that becomes a very big engineering challenge when it comes to that point. Also, the detector is located right over here. The light is directly falls. There is no secondary mirror. The light doesn't go bounce back. So there is no center hole on these mirrors because light is just collected over there. Apparently, you cannot look into anything visually with that telescope. You can only get the scientific data. So speaking about scientific data, we talked about like there is nothing to look directly with these telescopes. But okay, what do we get then? What do we record from these telescopes?
I have to ask though, Levent. So this McDonald Observatory belongs to UT, and UT Austin is in Austin, and the observatory is like 9+ hours away. Why would you build an observatory that's a part of your campus that's, you know, like 10 hours away? Hey, I've got to take a whole day's drive just to visit this telescope.
Well, I mean, apparently the answer is not that the property leases are expensive in Austin, so they decided to find a cheap place. No, that's not the case. There is a good reason that the observatory is 9 hours from Austin and 4 hours away from the closest city. I mean, I'm not counting Fort Davis. Fort Davis is a very small city, and I think with the moderate population, the closest city is Midland, which is about 4 hours away to the observatory. So, well, there's a mountaintop, right? And the observatory is built on the mountain. So there is a good reason for that. Why would you need a mountain, and why would you choose such an inaccessible location? Then I would like to ask you.
Can't be because you're just closer to the stars. That can't be it, right? I mean, we can let people in the comments. The chat's been kind of moving. We can let people in the comments if they want to answer that question. Does anybody know who's watching why we put them on top of mountains?
Can we leave the answer to that question to the end of the stream so people
we'll
can guess?
We'll put a poll up, and the poll will say
why they have to be far.
Yes, we'll give a couple answers. We'll make
do they get a maybe like a rent break or something on the land?
All right, Roman, just check the poll. We'll have the poll posted in just a few moments. It's gonna say you know, why, and then we'll give you some answers. We'll see what you guys think is most likely.
All right, so here is your question, and think about it and answer. All right, let's move on. We were talking about observatories. The optical observatories are not the only ones the astronomers use. There is a different type of observatory that we call radio observatories. We observe radio signals. Well, just like your radio receives radio signals, astronomers are not looking only interested the light coming from space. They are also interested in radio signals that is coming from the space. But hold on a second. Radio space, I mean the radio signals really coming from space? So what do you think? The radio signals broadcasted from the aliens' public radio transmitters? Of course not. There are actually many different mechanisms that is producing radio signals in space.
I need to comment just for the people watching. This is an image of Arecibo before it was destroyed recently. So this is an old picture. It's yeah, he's gonna destroy it again. That's that's 3 times, right? I mean, it got destroyed in that movie, James Bond. They blew it up, and then it got actually blown up, or it fell apart just a month ago or so. But this is before in total. I guess when it was completely intact.
Yeah, there is a video on the internet that giant detector actually free falls directly on the surface of this large dish. So this is actually a dish antenna, very much similar to the dishes people, I think, still using to get dish TVs. So this is similar to that. But again, the radio signals are coming from space. And those radio signals, turns out, produced by some radio signal making processes like neutron stars, pulsars, for example. They are highly spinning stars. So when the stars spin at very fast speed, they make electrons also spin with them, and spinning electrons cause radio signals. And those radio signals we can pick up, and then we can analyze it, and we can do a lot of science with it. So here's another example. There's a giant farm of dishes. So this is what we call VLA, very large array. So the difference is there is no one single giant dish. There are series of dishes that all pick up the signal from the same source, and the computers combine the signals, and then we get a lot better signal quality by combining the signals. So we are using those big arrays.
So just while I was gathering images for this thing, I noticed that at the VLA, these telescopes or satellite dishes, whatever you want to identify them as behind you, they're on what look like railroad tracks. Do you know anything about this?
Well, I think that yes, there are railroad tracks, and it's a good idea because they can just move the telescopes as needed, because sometimes they need just the telescope separation be farther apart from each other. Well, you know, we said the telescope, the radio signals from space are not coming from alien public radio transmitters, right? But there is actually a very famous project called SETI, S-E-T-I. The group of scientists, and those are real reputable scientists I'm talking about, they are actually looking for intelligent signals that may possibly be transmitted by a intelligent civilization. If we think about ourselves, if we count ourselves as intelligent form of life, which I think we are transmitting signals all over the universe for the past 100 years. So that means our first radio signals reached out to 100 light years away from Earth. So if there is anybody listening at 150 light years away from us, they will have no idea about those signals. But similarly, scientists thought that if there is the radio signal ever broadcasted in space in the universe, so that radio signal may be picked up by a radio telescope. And we can see if it's coming from an intelligent life like us, And to be able to do that, so they just started this project. But it was extremely tough to get observation time because that required scanning the entire sky all year around. They are not able to use much time in these large telescopes. So, and later they did some fundraising, and apparently the fundraising was successful, and they are now building their observatory, which is called, I think, ATA. If I remember correctly, that telescope field is located in California.
Let me pull that
All right.
visual back up in a moment.
So radio telescopes are used for the scientific researches, and also used to search for extraterrestrial intelligent life.
Levent, we did title this live stream as the biggest telescope. So these radio dishes are the biggest telescopes on Earth for sure. I did round up an image of what is maybe, or depending on how you want to argue it, the biggest radio telescope on the planet, because a lot of these are multiple dishes. It's kind of hard to calculate the real size, I mean, in comparison. So I do just want to take a moment to show everybody so that we pull the promise. This is called FAST, or the 500-meter aperture spherical telescope. That is a mouthful there. It's on the thing. This is in China. This is the biggest. It's 500 meters across, and Arecibo would fit in like the middle circle down in the bottom. This one is just, it is insane. It's unbelievably big, just enormous. So we did follow through with that promise for the sake of saying it.
That telescope is certainly large. All right, so what else?
I'm going to grab that, the SETI A, what did you call it?
Yes, I think it's called ATA,
Yeah,
if I remember correctly. Or
either
the site is called ATA, or the telescope observatory is called ATA, one or the other. But yeah, this is how they look. So they are building those dishes, and the purpose of these dishes are going to be just to search for extraterrestrial intelligent alien life signals. So we'll let you know if they find any, but hopefully in the future.
All right, so these telescopes that we have all over the world, I mean, you already discussed that astronomers don't sit behind the eyepiece and look through it.
Yes.
But what else do they, if they're not sitting behind the eyepiece, how are they collecting this data in any sense that maybe you could explain to somebody who, you know, doesn't have research experience?
Yes. Well, the light, after the telescope collects the light, and it may take several hours depending on the brightness of the object, and for some dim stars, for example, I know it takes sometimes hours of time to collect good enough data. So let's see how it works. If we can bring this picture. So here is a very simple diagram of what happens to the light after the telescope. So here the light comes and it goes to an optical element, then leaves the optical element and goes through some mirrors and lenses, and those are used for corrections, and finally they end up at what we call CCD. CCD is just a camera, pretty much the camera we use in our cell phones too. Those are also CCD cameras. So that CCD cameras record the light after it is processed by all of these optical elements, and finally the final image or final data is recorded by a PC. So in the PC you usually have like a bunch of numbers that has a scientific meaning. Otherwise, it doesn't have any just around numbers.
All right, I got to cut in. Just we had a good question from Kurt Copeland. Kurt Copeland asks, "Are they going to fix Arecibo?"
To my knowledge, no, because the fix was very expensive. The Arecibo telescope was already in jeopardy for funding. So the government was discussing or deciding not to fund the projects anymore. And the last thing I know was the projects were going on with like minimum funding, because they just decided to just fund the observatory at minimum bare bones just to go through the observations. But after the destruction of the telescope by an earthquake, they said, no, absolutely, we are not fixing anything. So it's not going to be fixed, unfortunately. But fortunately, there are better and bigger telescopes are being built all around the world. So that's a good news. All right, so let's go on our next image. And after you have this and you got all the numbers, PCs spend some time to crunch numbers. And finally, we end up with a plot like this. Let's show the plot. And here, for example, this is a data. It may not make any sense to you, but it has a lot of meanings to me. This is an absorption line. So I can see at one frequency, which is around at 6,560, the light is absorbed. So this line, this is called H-alpha line, very famous line. But these type of lines have a very, very important meanings for science. We can find out the chemical composition of stars. We can find out the rotation rates, and if multiple stars are involved, we can also find their the space velocities, etc., just using those lines.
So I need to just quickly go, if you're watching and you didn't hear the thing about a poll, there's a poll. You should see it at the bottom of your video. Go ahead and fill it out, asking about why we build telescopes on top of mountains. At this point, everybody said closer to the stars, which was I just want to say, we can't see who selected what answer for the poll, so it's totally anonymous. But that was a joke. In some small way, it is kind of true, but just a heads up. We can show the poll again real quick just to see what it says. We'll go ahead and publish that down below.
I see a comment, personally own a Meade ETX 125, the non-GPS kind by John Husley. Well, non-GPS kind is the best telescope probably you would ever get. And if I buy today a personal telescope, I would stay away from the GPS kinds and even like a computer-controlled, computerized telescopes, because the electronics and gears are pretty cheap on those, and they fail after a few years owning the telescope, even if you just keep in the best conditions. But the optics is the most important part, because this is your image quality. It's determined by the lens and the mirror's quality. So again, at the telescope episode, I said spend most of your money in optics and least amount of money in electronics and GPS and things like that. So let's...
All right, so I have to say, we've gone through all these different telescopes, and the radio telescopes and the regular visual light telescopes. If radio telescopes can see the stars during the day, and clouds and daylight don't really affect them as much as they do with a nighttime optical telescope, why do we have any need for space telescopes? Like, what's their purpose?
Excuse me. Okay, let's come back to the famous image I like showing frequently. So let's actually this will answer your question about the location of the observatories too. So here is your horizon, okay, and there is that like a all type of light raining down from space. So with the astronomical observatories, the optical observatories, we are looking at that part, optical light. So optical light means the light comes in our the optical visible range, and that range is we see colors of starting with the red, and then yellow, green, blue, let's say magenta, violet. So these are all optical light. So there are other type of light than those, but let's see what happens. So our Earth, the air, is letting these type of light through. It is absorbing it. So when from space to reach to the ground, the light needs to travel through the air layer. And when light is traveling through, light is getting weakened by the air molecules. For that reason, so the amount of light we get on the ground is weak. If we locate our observatory high up in the mountain, there is a less travel for light to travel. With other words, actually, like Braxton said, and some other audience members said, it is close to the stars. That's true. So because this location is close to the stars, it makes the best places for observing. But there are other reasons too. For example, humidity is lower at mountaintops, and humidity is bad for optics. Also, light pollution is less in mountaintops, so the light pollution is the enemy of astronomical observation. So we are trying to get rid of this light pollution. There is another thing. The most densest layer of the air is close to the ground. So the air gets thinner and thinner, and that's why if you have respiratory problem, you shouldn't go over the mountain because it's going to affect you, because the air is less thick. So the thin air it makes the breathing difficult, but the less air means less absorption for the light.
Speaking of light pollution, you mentioned that earlier, Levent. I don't know if you've heard about it. I assume you have. If you've been out to Fort Davis any time recently, I saw an article. It was probably a year ago at this point. Maybe it was longer. It's hard to tell with 2020 and all. That talked about light pollution becoming an issue at Fort Davis because of all the natural gas drilling and all of those sites set up with just tons of blaring light. Last time I was out there, not only did I see, on the way out there, an immense amount of just like construction trash, but I also saw like an unbelievable amount of wells. It seemed like comical.
Unfortunately, this is the fortune of a lot of observatories. At the observatories, they pick location once, and apparently McDonald Observatory's location was picked long time ago. I think that the observatory is there from like 1920s or 1930s. At that time, that was a very remote location and nobody cared. But right now, all the industry and especially the gas drilling and etc. is coming to the land, and there are more activity. And when there is more activity, all the decisions are economical. So if there is a benefit like taking the gas out, so sometimes the decisions are being made not in favor of science, but in favor of more money. So this is typical.
Just to confirm, it was finished. It was completed being built. The original 82-inch telescope in 1939. So you were definitely correct.
So it's pretty old observatory. In here, let me take your attention to the other type of light. So we talked about the optical observatories, and we talked about the radio observatories like this. So our air also treats the radio signals the same way as the optical signals. They let them go through. But if you look over here, there is an infrared light also coming from space. Well, we see a portion of the infrared light on the horizon, but in here, the big portion of the infrared light is actually blocked by the air at about 10 kilometers high from the ground. So if your observatory is over here, it doesn't see any infrared light. So for that reason, NASA built a telescope and installed it on board of an aircraft. Yes, you heard it right. There is a telescope on board of an aircraft. It's called SOFIA, Stratospheric Observatory, and it flies high to get the infrared signals.
Hey, don't we have a professor, Dr. Manfred Kunz? Didn't he worked with Sophia for something?
He not only worked with Sophia, he actually flew in Sophia aircraft as the guest scientist. It was amazing. And here in the ultraviolet region, there are ultraviolet rays also raining down from space. We cannot get them. We get only one portion, small portion of ultraviolet light. And this one is actually what is causing skin cancer. So that's why we put sunscreen on. And if you check your weather app, there is also a parameter in the weather apps called UV index. That UV index is, if it is high, that means you are getting a lot of this, and you have to wear like maybe shield or put sunscreen. So you are getting this light, and this light is not good one. So fortunately, most of them are blocked by the air. So if you need to observe something in the ultraviolet light, you need to go to space. And also in the X-ray, it's the same story. We are lucky that we are not getting any X-rays. It is all absorbed and blocked by the air because the X-rays are DNA damaging. If we were getting X-rays on the surface of Earth, we would not be able to survive on the surface of this planet. Gamma rays, we are getting some gamma rays, but not intensely. So they are being blocked too.
I mean, we can see like a little air balloon right there. Do you have any idea what that like V2 looking spacecraft is over there? I've never seen anything like it before.
Yeah, this was put over there to just mention the altitude. So the only rockets go 100 kilometers high. The airplanes don't go that high. So this is pretty much like the boundary of the air and space. So the rocket shows you are in space. There is no more air over here.
That makes much more sense.
But the air balloons may just go to the boundary, but not go further than that, because it's air balloon. If there is no air, it's not going to be able to fly. All right. So who is the winner of the ballot?
The poll, we can publish the poll results and see, but I'm not sure. It looks like everybody. We don't have too many people participating with the poll, but I mean, they're both kind of right in a way. Less light pollution, closer to the stars, less rent.
But actually, all the answers are true. I mean, there's less light pollution. It's closer to the stars.
At least to some extent.
And mountains are cool. I mean, they are cool. They are cool, which like if you are making like getting the cool in the nicer meaning, they are nice. But also temperature-wise, they are cooler too. So I wouldn't oppose if anybody answered mountains are cool.
We just witnessed somebody switch their answer to less light pollution.
And less rent is also not an arguable result. That's not the primary thing they are looking for, because they are looking for best place to put their electronics and optics. So they are mountaintops, but not because of they are cheap. They actually, the observatories, the remote observatories actually cost more money in the long run, because you have to maintain, you have to take all the resources and logistics to the mountain. So that costs more money than your observatory was actually in the urban city, than you would pay like a higher rent.
All right, we just got a question from Roman, who asked, will the USA beat the other countries to put the first telescope on the moon? I don't know if you have any comment or you want to add to that, Levent.
Well, if they want to, they can, but we need to think about whether that makes sense to put a telescope on the moon or not. So the moon orbits around Earth approximately every month, and your telescope will be stationary telescope on the surface of the moon. Obviously, it needs to be on the dark side of the moon. There is no function of the telescope if it is facing Earth. So if you put your telescope away from Earth on the dark side, you would only sweep the sky once a month. While instead, you have a space telescope, you can put it on the Earth's orbit, and you can rotate and orient it as needed.
Isn't the James Webb Space Telescope supposed to be beyond the moon somewhere?
Yes,
Maybe
James.
Lagrange point. I'm not sure off the top of my head.
James Webb Telescope exceed the moon's distance by 3 times. One of the benefit of putting a telescope on the surface of the moon, it is hard for a telescope to keep it in a stable orbit. So you launch the telescope, you put it in orbit, but you continuously run the tiny engines on the satellite to keep it in a stable orbit. Otherwise, it will either drift away or fall back on Earth. So if you put your telescope on the moon, it would be stable. But the scientists found another way to put a telescope in a stationary location, and that is the Lagrange point.
We have another question from Kurt, who asked, will space-based telescopes replace Terra-based telescopes, or are there benefits for keeping Earth-based telescopes?
That's a good question. The space telescopes do not replace the ground-based telescopes, but complement it. And how? And as they explained over here, all the different type of lights. If you are observing ultraviolet, X-ray, gamma rays, you have to get a space telescope because signals don't make it to the ground. But the problem of space telescopes are, yeah, they are getting better signals, but they are very expensive to maintain. If your signal is reaching to the ground, like optical and radio, there is no point on putting your telescope in space, because you can, at the fraction of the cost, put astronomical observatories on ground. They are less expensive to maintain and a lot easier to fix. Like if somebody decides to put bullet holes in your telescope, you can fix it.
I think when they first sent the Hubble up, right, there was something wrong with it. It was not in focus, and then we had the space shuttle, so it was able to fix it. But still, I can only imagine how much money that had to have cost just to go and make some adjustments or replace a sensor.
Yeah, I remember that missions, and I think there were like 4 missions, and I watched all of them. First, the space telescopes were not intended to be serviced, because they just estimate lifetime of like 10, 15 years, and they put it up there and hoping that the satellite to survive that much. But the problem with the Hubble was, like, immediately after they put it in the orbit, they realized something wrong. And apparently, telescope was going into the trash can right after its launch. So that's why they had to spend extra money, and it's not easy, because space, you need to send a space shuttle. Space shuttle needs to go and capture the satellite in place, which is not an easy process, very delicate process. And after captures, astronauts go outside and fix the problems, and they come back. It's a lot of work.
All right, Levent. So it looks like we've kind of covered all the material. I do want to just let everybody know for next week that we are going to drop a poll in the chat that's going to ask about what you guys want to see. If there's some topic you want us to cover in particular, we're happy to cover it. You can just leave it in there. Otherwise, respond to the poll. It'll be on the video. It'll be live on the video anytime you watch this back from now, maybe indefinitely. I don't know. But at least for a week. And that way we'll have a better idea to give you guys what you want to hear next week. We do have a couple things in mind, so we're probably going to go with those. I do want to mention a couple more things. We're having a little bit more detailed live stream on February 10th. Is that right, Levent? I think it's 10th.
Mm-hmm.
Normal time, Wednesday at 1 p.m. This is going to be in-depth about the moon, and we may have a special surprise for you. Sorry, about Mars. We may have a special surprise for you. And then on February 18th, because we will have Perseverance, the Mars rover Perseverance will be landing on the surface of Mars. We're going to do a special live coverage of the entire thing. So we'll update you more on that when we get to it. It looks like Levent has some show and tell.
I just found a space telescope. This is the replica of Hubble on my desk. Do you have any idea why it was sitting on my desk?
I have no idea why. That stuff comes and goes, and yeah, I think we have another one upstairs too.
All right, so we'll come back with another topic next week. Feel free to ask your questions either before or during the live stream, and we will be happy to answer your questions. And see you all next week.
See you.